impedance. So one of the advantage of negative feedback is it is used to increase the input impedance, and also it is used to decrease the output impedance. So both the concepts we are going to study today. To study that or to prove that, let me consider Vi be the input voltage and II be the input current through the input impedance of the feedback amplifier, which is represented here. So Vi be the input voltage, II be the input current to this particular basic amplifier that flows through the input impedance of that particular amplifier. Then that particular input impedance is given as ZIF is equal to Vi upon II. Let me call this as an equation number 1. The net input to the basic amplifier is Vi dash equal to Vi plus K times Vo dash. Let me call this as equation number 2. How it is possible? So Vi dash is the new voltage which is obtained by considering the feedback voltage, that is K times Vo dash, which is either added or subtracted from the original input voltage. And that new input voltage is here represented by Vi dash is equal to Vi plus K into Vo dash. Friend, this is the concept which we have already studied at the beginning of this particular topic when we have studied the general theory of feedback and also the concept of feedback. By using that particular concept and by using these particular block diagrams and terminology used, that is Vo dash is the voltage, part of that, that is K times Vo dash, it is the feedback voltage. Maybe it is going to be added or subtracted from the input. Most probably, as we are using here negative feedback, it is subtracted from the input voltage. With that particular aspect, the new voltage of feedback amplifier becomes Vi dash is equal to Vi plus K into Vo dash. Let me call again, this is equation number 2. The input current to basic amplifier is II, which we have represented here. The input impedance without feedback is given as Zi is equal to Vi dash upon II. Let me call this as equation number 3. But Vo dash is equal to AV into Vi, that is output voltage is amplifies the input voltage by gain times. So by that particular aspect, we can write Vo dash is equal to AV into Vi. And also from equation number 2, that is from this equation, Vi dash is equal to Vi plus K times Vo dash. Put it in this particular equation. If you replace Vi dash is equal to Vi plus K times Vo. Now if you replace Vo dash by AV into Vi, we are replacing this Vo dash by AV into Vi, so as to equation 2 becomes Vi dash is equal to Vi plus K into AV into Vi dash. By performing mathematical manipulations, that is by taking K into AV into Vi dash to the left side, so that Vi dash minus K into AV into Vi becomes equal to Vi. Let me take Vi dash common. Let me take Vi dash common, so that we have to get Vi dash equal to 1 minus K into AV, that's equal to Vi. Now divide both the sides by input current II to get Vi into bracket 1 minus K AV upon II is equal to VI upon input current II. That is VI upon II is ZI. From equation number 3, ZI into bracket 1 minus KV is equal to ZIF, VI upon II. Therefore, we can write it ZIF is equal to ZI into bracket 1 plus KAV, by the consideration that for the negative feedback K is negative. This equation indicates that input impedance after feedback is greater than that of input impedance before feedback. Thus, we can say there is an increase in input impedance when the negative feedback has been applied. Similarly, we are going to prove that by applying the negative feedback, one can decrease the output impedance. Friends, output impedance is most advantageous in an amplifier. Due to that, it is capable to deliver the more power without being much loss in the power. And this is again achieved by employing that negative feedback. To prove that, consider the block diagram which is represented here. In this particular block diagram, input source is reduced to 0 and we have connected only output source VO. From that output source, part of that is K times VO is feedback to the input. Let ZO be the output impedance and A into K into VO be the input source which we have being used as far as basic amplifier is being considered. The role of feedback network is to feed the part of the output voltage VO, that is a voltage source which you are connected externally, KVO, back to the input. That means to prove that there is a decrease in output impedance, what we have considered, we have reduced the input source to 0. We have connected output source VO only. Internally, it has got its input impedance ZO, having the source as A into K into VO as far as basic amplifier is being considered. With these considerations, we can say let ZO be the output impedance without feedback. To find the output impedance with feedback, the input source Vi to the feedback amplifier is reduced to 0 and voltage source VO is connected to the output terminal. So this we have connected. Let IO be the current from the applied source, means from this particular source. IO be the current that flows with the voltage at input terminals of an amplifier is K into VO at its output. Due to this, input voltage for output loop is K into A into VO. The voltage equation for output loop now becomes VO into K A into VO, that is equal to IO ZO. Take VO common. VO into bracket 1 minus K A equal to IO into ZO. Take this IO to the left side so as to get VO upon IO equal to ZO upon 1 minus K into A. But for negative feedback, as usual, K is a negative and VO upon ZO, VO upon IO, it is ZOF. Therefore, this equation becomes ZOF upon ZO upon 1 plus Ka. As denominator is more, ZOF is less than that of ZO, indicating that when negative feedback is applied, there is a decrease in output impedance, and which is most advantageous and can be used to deliver the more power without being much loss at the output load terminal. Friends, This is how one can prove that there is an increase in input impedance and also there is a decrease in input impedance and also there is a decrease in output impedance.